How do you simplify radicals with absolute value signs? Imagine you're solving a puzzle where the pieces are numbers and symbols, and your goal is to make everything as simple as possible. Sometimes, in algebra, those pieces include radicals with absolute value signs, and understanding how to handle them is key. When you see a radical with an absolute value, it's like a clue that tells you to be careful about the sign of the expression inside. First, you need to look at the root's index. If it's an odd number, like a cube root or fifth root, you don't need to worry about absolute value signs. That's because odd roots can be negative or positive, just like regular numbers. For example, the cube root of -8 is -2, and the cube root of +8 is +2. So no absolute value signs are necessary here. But if the root is an even number, like a square root or fourth root, absolute value signs become important. This is because even roots of negative numbers are not real, so the result must be non-negative. When simplifying, you want to make sure the answer always makes sense in the real number system. Next, you simplify the expression inside the radical. Break it into perfect powers based on the root's index. For example, if you have a square root of a number, look for perfect squares inside. If you have a fourth root, look for perfect fourth powers. Extract those perfect powers outside the radical. Now, here's where the absolute value signs come into play. When you simplify an expression like the square root of x squared, the answer is the absolute value of x. This is because x squared is always non-negative, but x itself can be negative or positive. The square root must give a non-negative result, so you write it as x. Similarly, if you have a radical of a variable raised to an odd power, like the square root of x to the fifth power, you need to include absolute value signs to keep the answer correct. For example, the square root of x to the fifth power simplifies to x times squared, because the absolute value ensures the result is always non-negative. Remember, the main rule is that for an even root, the simplified form should include absolute value signs if the variable's exponent outside the radical is odd. This way, the expression stays true to the property that radicals always produce non-negative results. For odd roots, you can skip the absolute value signs because the root can be negative or positive naturally. Let's look at a quick example. Simplify the square root of 36 times a to the 8th power times b to the 12th power. First, break down each part. 36 is a perfect square, so its square root is 6. The 8th power of it is a perfect square, so its square root is a to the 4th power. The 12th power of b is also a perfect square, so its square root is b to the 6th power. Multiplying all these gives 6 a to the 4th power b to the 6th power. Since all exponents are even, you don't need absolute value signs here. But if you have the square root of x squared, the answer is x because could be negative. The absolute value signs ensure that the simplified form always gives a non-negative result, which is what the square root should do. In summary, when simplifying radicals with absolute value signs, focus on whether the root is even or odd. For even roots, include absolute value signs if the variable's exponent outside the radical is odd. For odd roots, you can leave out the absolute value signs because the root can be negative or positive. This rule keeps your answers accurate and consistent with the properties of radicals. Think of absolute value signs as a way to protect the non-negativity of your answers, especially when dealing with even roots and variables raised to odd powers.